can effective highways repairs only be achieved with hot works materials? And I think we'll start with Hassan.
Thank you very much for this question. Basically, we need to here define the hot work materials. If we are talking about hot mixed asphalt, we need to see whether we are talking about the normal hot mixed asphalt, which we normally use for road surfacing, and the temperature range is usually more than 130 centigrade. It's a bit more than this one, 140 to 170. There are a lot of material which is produced, since the technology of the road surfacing started using hot mixed materials, and we have now the warm mix, and we have the other materials which is highly developed. So the answer, if the repair place is being constructed and the material being laid, hot, to the specification, compacted to the specification, the answer is yes. The hot mixed asphalt is a good material for that. But the cold mixed asphalt, since 1957, that's the approximate time at the USA, the cold mix material produced, and the people tried to use the material, and they found that it needs a curing time of 2 months to 24 months. Since then, the material went through a lot of development, and today, especially at Liverpool John Moores University, we managed to reduce the curing time to less than 1 day. Also, work has been done at Germany and France. They replaced the limestone filler with OPC, and the OPC is, as you know, ordinary Portland cement, and that's material. Every 1 ton of the OPC need produce 1 ton of the CO2 emissions, so it's not a friendly, environmentally friendly material. Now, the material which is now used on road, and they are cold materials, some of them work, some of them is not. So therefore, a lot of work is really required, at laboratory research center, as well as in companies, for these materials to be developed further, and also prepared, the site prepared and laid, compacted to the specification. There are a lot of problem with the checking these materials, especially if you are using the SROH, simply because of the condition of the roads as well as the material during its lay, and we will cover this one later. Thank you very much.
Thank you. We'll stay on that side of the panel. Carl?
Okay, so effective highway repairs only achievable with hot work material. So, is it just that simple? Everything and anything to do with the roads is never quite that simple. So, hot mix material. So, there are lots of different versions of hot mix materials, apart from the individual grades and mixes. We've got standard mixes. The utilities have an enhanced mix, which has got slightly more bitumen in it to make it easier to lay and to compact. We've got now coming in quite fast warm mix materials. Warm mix materials are relatively new, particularly to smaller operators. The big operators have been working with them for some time. And then at the far end of the scale, you've got materials that can be mixed, batch mixed on site and don't require compaction. So you've got the flowable mastics. If we go to cold lay, so what do we mean by cold lay? So there's 4 basic types of cold lay. You've got emulsion, which is a water-based. You've got a solvent-based one, which as you compact it, evaporates out. There's a cementitious one, which actually works brilliantly in water. And then you've got the MMA materials. Each one of those has its own characteristics. Each one of those has its place, and each one of those will have a time frame that it will last. You know, the more expensive materials last much longer, and it's a balance, in my opinion, between the size of the excavations that you're working on, is there a tarmac plant nearby, how far have you got to transport it, how long is it going to be in the vehicle, how much do you actually need, if you're going to buy a ton, do you need a ton, and the whole life cost, not only in monetary terms but in environmental terms, of using a superior material can actually reduce your costs and reduce your emissions. So, not a simple answer. There's a place for all of it, in my opinion, depending on the scale of the works that you're doing.
Thank you. We'll come across the barrier on that one.
Matt, thank you so much. For the debate on whether effective highway repairs can only be achieved using hot mix materials, the door is ajar. I think that's the best way we can say it. You've just heard from Carl that there are many characteristics associated with the cold mixes that give us advantages when it comes to looking at the scale and size of the repair requirements. So, whilst we can understand that these materials are proven in situ, it does mean that each use has to be assessed from each company's own perspective. So there might be contract-led, there might be requirements that are actually legislative. But for the majority of uses, in my opinion, the cold mix does offer some great advantages. So what we have are safety considerations. Cold mix can be laid without the need for heated bitumen warmers. The technology is proven, so the market can gain advantages from knowing that the materials meet the performances as stated, and that can be demonstrated too. We know that actually, particularly now when we're looking at sort of budgets and sort of local authority spending and utility costs, then money-saving initiatives will always sort of percolate to the top in anyone's consideration, particularly around budgets. So cold mix again offers great advantages over the hot mix materials. Whilst there has always been a proven benefit for laying hot mixes, that is scale. So much larger sort of repairs are undertaken using hot mix, and as Carl alluded to, there we've now introduced warm mixes. But for the small scale utility considerations where there are reinstatement works or immediate emergency repairs, then cold mixes definitely have their place. And it is therefore the consideration of the phrase effective repair that opens up the debate to everybody. So I think at that point I'll hand back to you, Matt.
Well, I'll push it straight on to Russell and just ask for your thoughts.
Yeah, no, thanks very much, Matt. I suppose let's go back to John Loudon Macadam, born in 1756. So he pioneered the construction of roads in Great Britain, unrivaled since the Roman times. And then moving on to 1902, when Egbert Hernal Hooley, he pioneered the introduction of asphalt and tar with steel slag, and we started to see the asphalt paving coming into this country. What we have to understand here is, as a nation, as an industry, we know and love hot works. We know and love the hot asphalt material. But is it the only way that we can repair our roads? And the answer is very simple, in my view, is no. There are multiple, as Carl's already explained, multiple different coal-applied systems that are effective. They can actually outperform some of the hot-applied materials and systems that are out there. And they should definitely have a place in the industry, and they do have a place in the industry. and it should be something which we can develop and investigate further and embrace. So back to you, Matt. Really, I think that.
Well, I guess that brings us into a debate, doesn't it? First 5-minute debate. So, if we're saying that hot and cold solutions are both potentially viable, how important is it that we look at the safety, at the cost, when we're making that decision? Who wants to take a lead on that?
So I think cost-wise, industry will lead that. You can't force somebody into accepting something. There's, having worked in utilities for most of my engineering life, cost is a huge thing. The thing with cost though is getting over to people that paying a little bit more is actually in most cases cheaper. So buying something which is a better material that performs better in the long run, or the whole life cost of the reinstatement actually comes down, because any reinstatement that doesn't last for its guarantee period is hugely expensive to go back to, and a massive waste of time and effort and environmental resources. So yeah, it's a learning thing for people to get over that sometimes things that are slightly more expensive are actually cheaper.
How do you think you tackle that education then, convincing someone that spending a little bit more is actually cheaper?
Well, I'll take this one. So for ourselves, we were debating about effective repairs. And as Carl's explained, if effectiveness means that everybody understands why, and that it lasts for a great length of time, then it makes common sense that actually within the industry we spend some of our time, some of our resource educating and training the engineers and the operatives that we have working for us, in getting them to understand what materials are out there, the actual practices, the benefits that are provided. That's not just engineering professionals that benefit from this, because then you start looking at your budget managers, your financial institutions, you look at the material suppliers. They understand actually what the characteristics are of the products, and then can help and advise and inform, which is again a benefit to our whole industry. So whilst I come from a background of the written word where we explore what our policies are and why we need to have these things in place, the true benefit to our industry is through education, and that is not just education on how to do the job. That is education of the benefits that these other alternatives will offer our industry in the years to come. So if you then match that with your key performance indicators and your sustainabilities, we are going to open up another field for debate.
Does anybody find on that effort to educate that sometimes you face the sort of, well, this is just how we've always done it approach? And if so, how do you get past that?
I think, if we take, the where innovation, and collaboration. What I mean by collaboration here, the people who are making the policy, the people who are implementing the repairs, and also the councils. These people meet, together, and they understand, the situation. Definitely, cold mix asphalt repair has many advantages. One of them is the health and safety. CO2 emission will be less. And also, if the cost is very acceptable, then the whole life cycle analysis will be a benefit as well. And so that means, if we looking at the material itself, and do the link, between the invention, the innovation, and also the collaboration, we will meet, will come with the system to the repairing, whereby we can meet the specification required at the target required as well.
Thank you. Anybody else got anything to add there?
Yeah, I'm just thinking that it really, when it comes back to selecting the product, it's based on scale. So what's the scale of the repair, and then understanding what product fits where. So what's the right product for this repair? What's the right product for this type of road? What's the right product for this utility contractor to be using, you know, in an urban area, for example? And maybe the repairs that are being done at night, you know, how can we reduce noise impact and that sort of thing? So definitely it's around scale and understanding what is the right product, and the education piece, I think, is where we need help as an industry.
I think that brings question one nicely to a close then, gentlemen. So if we move on to question two,